Hello everyone, this is lecture 3 of week 9. Please recall that in the previous 2 lectures we learnt about simplex method. We first started with linear programming problem and discussed some properties of linear program, right. So, we said that the constraint set will always be a polytope and at least one of the vertices of the polytope will be one of the solutions, right. And we started with simplex method. The first thing that we discussed was that we need to find some vertex, and how do we find that? We first convert the given problem to standard form, right. So, standard form is min C transpose x subject to A x equal to b x greater than or equal to 0, where A is an m cross n matrix of rank m, right. So, and after that we saw that the matrix be split into the set with basic variables and the other with non-basic variables, right. So, the solution of the basic variables was b inverse b, and the solution of non-basic variables was equal to 0, right. So, that I mean whenever that happens, it is a vertex, and any vertex can be written of this form, right. So, all that was learnt in the previous lecture. We will continue in this lecture. So, if you look at so this was what I was discussing. So, you can recall that B is a set of m linearly independent columns of A, right. So, yes, yeah. So, suppose you had the rank of A to be less than m, then yeah, you need to choose row linearly independent columns of A dash, and because of that that will become the resultant set of constraints, right. So, yeah, if A had all these vectors A1, A2 dot An, right, and if you choose any m linearly independent vectors, right. So, you can construct vertex from that. So, you choose xb as b inverse b and xn as 0, right. Okay. So, let us actually work with an example, so that yeah, you actually understand how you actually choose the basic variables and non-basic variables. Okay. So, yeah, of course, you might have known by now that the set of linearly independent vectors that you choose from A1 to An need not be unique, right. So, we will see that in the example that we were considering, right. So, we had this particular example, right. So, where you had a triangle with vertices 0, 0, 1, 0 and half half, right. So, the A matrix that we had was this, right. So, the problem, so in the example, right, we have the following problem, which is min C transpose x subject to A x equal to b, but A is as given here minus 1 triple 1 0, 1 minus 1 0 1. So, let me copy that down, right. So, minus 1 1 1 1 0 and 1 minus 1 1 0 1, right, into x1 x2, right. So, that is b, if you recall was just 0 and 1, right. So, again yeah, so this is b, right. So, you have 0 and 1. So, this is the problem, and of course, you have so this is this is the equality constraints that you have, and x1 x2 greater than or equal to 0, right. So, you have a 2 cross 5 matrix, and you need to choose 2 columns that are linearly independent, right. You can see that out of these 5 columns, 1 and 2 are dependent, right, because when you multiply the first column by minus 1, you get the second column. So, 1 and 2 are dependent, but every other pair is actually linearly independent, right. So, 1 3 is linearly independent, 1 4 is linearly independent, 1 5 is linearly independent. Similarly, 2 3, 2 4, 2 5 are linearly independent, 3 4, 3 5 are linearly independent, 4 5 are also linearly independent, right. So, you actually have 9 pairs of linearly independent vectors. Okay. Let us check. So, what that means is that the B that I am choosing here, right. Yeah. So, the A1 to AM that are linearly independent, right. So, that can be chosen in 9 different ways. So, we will try all the 9 different ways, okay, and check, yeah, what are the vertices that you are getting. So, I mean, from the problem we actually should get only 3 vertex, right. So, let us see if we are getting the same 3 vertex from all these 9 or what we are getting. Okay. So, this would actually serve as a practice to understand what basic variables and non-basic variables are. Okay. So, note that this actually corresponds to, okay, I think I have to, so yeah, this actually corresponds to x1 plus, this corresponds to x1 minus, this to x2, this to x3 and this to x4. So, I am sorry, yeah, this, okay, I will make a minor change here, yes. So, this has to be x1 plus, x1 minus, x2, x3 and x4, yeah, I am sorry. Yeah, now it is correct, x1 plus, x1 minus, x2, x3, x4, all of them must be non-negative, right. Yeah, so fine. Now, so we know that x1 plus and x1 minus are not, the columns corresponding to x1 plus and x1 minus are not linearly independent, but x1 plus and x2 are linearly independent, right. So, let them be the set of basic variables, right. So, in that case xn will be x1 minus, x3 and x4. Okay. So, now what is B inverse B, right. So, capital B is minus 1 1 and 1 1. So, this is x1 plus and x2, this is 0 and 1, right. So, yeah, just by looking at it, you can say that the answers are 1 and 0, right. So, because sorry 1 and 1 I think. So, verify it once. So, yeah, so you have minus x1 plus x2 is equal to 0, x1 plus x2 equal to 1. So, if you cancel this you have, oh okay, you get half comma half, I am sorry. Okay. Okay. So, x1 plus is half and x2 is half as well, right. So, yeah, minus half plus half is 0, half plus half is 1. So, that is all it is, and xn is actually 0. So, yeah, x actually turns out to be half, 0, half, 0 and 0. Okay. And you can see that this is actually a vertex, right, because yeah, actually x1 is, so recall that x1 is actually x1 plus minus x1 minus, right. So, half minus 0 is half, x2 is half, right. So, half comma half is actually a vertex. Okay. So, this I have got this vertex by assuming x1 plus and x2 as basic variables and the others as non-basic variables. Okay. So, let me do the others quickly. X1 plus and x3 are basic variables and the others are non-basic. Okay. So, you have minus 1, 1 and 1 0 are the I mean is the matrix under consideration. The right hand side is 0 comma 1. So, x1 plus is 1 and x3 will be 0. So, you have this as the point x, okay. The remaining I think you can fill. So, this is because I think yeah, you should have 1, if I am, yeah, this should be 1, sorry, yes, sorry, yeah. So, this is minus 1 plus 1 is 0 and 1 plus 0 is 1, right. So, the vertex here is 1 comma 0, right, and that is also a vertex, we know that, right. So, even using this we have actually got another vertex. So, we have actually got half comma half already, and 1 comma 0 also is a vertex that we have got. Now let us do for x1 plus and x4, right. So now we have minus 1 0 as 0, right. So this will be 0, okay. And so this is 1, so that will be 1, right. So that is because now you have minus 1 into 0 plus 0 is 0, and this is 0 plus 1 is 1, right. So this is also a vertex, we have got 0 comma 0, okay. So just by considering x1 plus x2, x1 plus x3 and x1 plus x4, we have got the 3 vertices that we wanted, okay. Though so you should actually ask what happens to the others, right. So we will see that, I mean some of them will be repetition and some of them will not be valid. I mean note that it is valid only when B inverse B is non-negative, right. So if B inverse B, I mean one of the elements for example were negative, then it is actually not a vertex, okay. So keep that in mind. So we will now consider x1 minus x2, okay. So I am not repeating this because it is just the negative of x1 plus, right. So whatever you get with x1 plus x2, the x1 minus will just be the negative. So that is, you will actually get this minus half, 0, half, 0 and 0, okay. So that actually refers to half comma half, sorry, it will be 0 comma minus half, I am sorry. So this will be 0 minus half and half, okay. So this also refers to half comma half, but this is actually not valid because x1 minus is actually negative here, right. So this is not valid because B inverse B is not greater than or equal to 0, okay. In a similar way you will get for x1 minus and x3, x1 minus and x4, okay. So I will just write that down for completion. You will have 0 minus 1 0 1 0, again this is not a vertex because B inverse B is less than, I mean it is not greater than or equal to 0, and here you will have okay. So here you just have zeros. So this is still a vertex because B inverse B is greater than or equal to 0, but you are getting 0 comma 0 again, okay. So whether you choose x1 plus x4 or x1 minus x4, you get 0 comma 0 anyway, right. So that is okay. So fine, and we still have 3 more to look at. We can look at x2 and x3, okay. So when you look at x2 and x3, you can see that x2 is 1, okay, but x3 is minus 1, okay. So you will have 0 0 1 minus 1 0, right, because 1 minus 1 is 0 and this is just 1. So this is also not a vertex because B inverse B is not greater than or equal to 0. Now let us look at x2 x4. So you have 1 0 1 1, right. So here of course x2 is 0 and x4 is 1, right. So okay, so this is a vertex, but it again refers to 0 comma 0, okay. And so we will finally write down x3 x4 as well, okay. So that is just 0 and 1 because it is an identity matrix, right. So you just get this again, which is again referring to 0 comma 0. So you have 4 pairs of basic variables that gives you 0 comma 0, x1 plus x4, x1 minus x4, x2 x4, x3 x4. So whenever you include x4, okay, basically you are getting the vertex 0 comma 0, okay. So but the other 2 vertices half half and 1 0 just came because of x1 plus x2 and x1 plus x3, okay. So I think this is now clear, right. So when you choose m independent columns out of A, right, the variables corresponding to those columns are xb and the other columns are xn, that is xb are basic variables and xn are non-basic variables. Xb will have the solution B inverse B, xn will have the solution 0, and if B inverse B is non-negative, then this combination B inverse B comma 0 is actually a vertex, and conversely any vertex is of the form B inverse B comma 0 for some B where B inverse B is greater than or equal to 0. Okay. So, we have actually succeeded in finding all the vertices of the problem under consideration. Okay. All right. So, now what is the next step? So, we recall that we have the problem, this problem min C transpose x subject to this problem, right. So, in general we will have this problem, right. We have min C transpose x subject to A x equal to B x greater than or equal to 0. Okay. So, now we have actually given a way to find all the vertices of a given linear programming problem, right. So, we have a polytope and there is a way by which we can find every vertex of the polytope. So, there is a very simple method to find the answer as well. So, if you know all the vertices, there are finite number of them. Okay. So, find C transpose x for all the vertices, okay. Whichever is the minimum, declare that that is the minimizer, right. So, that is a very simple brute force way of finding the answer, right. But of course, that is not a nice way because, so assume that, so we were able to find all the vertices in the example that we considered, right. The reason is very simple, it is because we had only 2 rows, right. So, m was equal to 2 and n was roughly 5, right. So, the maximum number of vertices that you can have is 5 choose 2, right. So, but in general that is not true, in general you will have n choose m, n could be say as large as 100, 1000 and so on, and m could be also as large as 50 for example 50 or 500 or whatever, right. So, suppose assume that you have n is equal to 100 and m is equal to 50, right. So, you will have to find out 100 choose 50 vertices, right. So, 100 choose 50 is roughly I think 10 power 28 or something, okay. So large, okay. So, so 10 power 28 you can imagine, 10 power 9 is 1 billion, 100 crores, right. So, 10 power 28 is much more than that. So, you do not want to find so many vertices and compute C transpose x everywhere, right. So, you need a much simpler way of doing this, right. So, that is what the simplex method is all about. So, simplex method is not just finding vertices. So, you start with a vertex. So, what we have done is to illustrate how to find a vertex, right, and after that you first after finding let us say you start with a B, okay, because of which you will actually end up with a vertex, right. So, after finding a vertex, the first thing that you have to do is to verify whether this is actually the minimum or not, the minimizer or not, right. So, you would ask me how would you verify it if you do not know the other vertices, right. I will tell you how you verify if a given feasible vertex is the minimizer or not, okay. So, that is the next step that we are going to work on, how to figure out if a given vertex is the minimizer. Okay. So, note that a vertex is of the form, so x star is xb star xn star, which is B inverse B and 0, right. So, suppose you leave xn star as xn star itself, okay. So, in that case you will actually have, so note that you have the constraint Ax equal to B becoming Bxb plus Nxn equal to B, that means xb equals B inverse into B minus nxn. Okay. So, you bring the nxn to the other side and pre-multiply by B inverse on both sides. B is invertible, please remember that. Okay. So, this is actually B inverse B minus B inverse nxn, right. Now, what is the objective function? So, objective function is C transpose x, or in other words it is CB transpose xb plus Cn transpose xn. Okay, I am just splitting x into the set of basic variables and the set of non basic variables, right. So, yeah, so I have written down xb here, right. So, putting that down, we will have CB transpose B inverse B plus Cn transpose minus CB transpose B inverse n into xn. Okay. So, yeah, I mean I have multiplied throughout by CB transpose. So, you have CB transpose B inverse B, you have minus CB transpose B inverse n xn, you also have a plus Cn transpose here, right. So, yeah. So, this is the value of the objective function. Note that, so suppose I call this as say theta n for example, okay, or yeah, this is a vector. So, let us say I call this vector as theta, okay. So, if theta greater than or equal to 0 component wise, okay. So, yeah, note that this is actually a vector, right. So, Cn is of dimension n minus m, okay. You can also verify that this is n minus m because B is m cross m, n is n minus m cross yeah, sorry, it will be m cross n minus m. So, B inverse n is m cross n minus m, and this is 1 cross m. So, this will also be 1 cross n minus m. So, there will be n minus m components in theta vector, right. So, if theta is yeah, greater than or equal to 0 component wise, then B inverse B 0 is the minimizer, otherwise it is not the minimizer. Okay. So, you should ask why, right. So, that is easy to see because suppose yeah, this vector, the theta vector whatever you have is positive, every element is non negative, right. So, if you increase the value of xn, instead of 0 you make it positive, then you are only increasing the value of the objective function, right. So, yeah, if theta is greater than or equal to 0 component wise, there is no need to I mean increase the value of xn, and you have actually attained the minimum. I mean the value of the objective function is minimized just by choosing xn is equal to 0, right. If not, let us say you have at least one component where theta is actually negative, okay. In that case I can actually increase that xn to further reduce the value of the objective function, and thus the minimizer is not actually attained, right. So, I mean that is as clear as it can be, right. So, if theta is greater than or equal to 0 component wise, then B inverse B 0 is actually the minimizer, that is we have chosen the right set of the linearly independent vectors, right. Otherwise, yeah, we have not chosen the right set, we need to modify, right. So, good, I mean that is I mean as easy as this, right. So, you just after finding the I mean taking a value of m linearly independent vectors forming a set of basic variables and non basic variables, right. You have a very simple way of finding whether it is a minimizer or not. What should you do? just find Cn transpose minus Cb transpose B inverse n. This is a vector, right. So, this is something that you can very easily write down in Python, right. So, you just write this down, check if each of the component here is non-negative, and if it is non-negative, then yeah, you have got the minimizer, otherwise you have not got the minimizer. So, good. So, it is good because I mean it is good when you have actually got the minimizer, but if you have not, then the problem is not yet complete, right. So, you have to choose another set of B now, right. But I mean again we would like to know if there is a simpler way of choosing a B now, right, because I mean I do not want to blindfoldedly choose another set of M linearly independent vectors again, right. So, what do we do now? Okay. So, what simplex algorithm suggests is, suppose you have given you have chosen a set of basic variables and it turns out to be not the minimizer, okay. Then you are going to modify the set of basic variables and non-basic variables in a particular way. What is it? You are going to exchange one variable from the basic set and the non-basic set. I mean there is going to be a mutual exchange. So, I will throw out one variable from the set of basic variables to the set of non-basic variables and take in one variable from the set of non-basic variables into the basic variables. Okay. So, I mean that is the heuristic that the simplex method suggests. In some sense you can say that you start at a vertex and you move to a nearby vertex, okay, instead of trying arbitrary vectors. So, what you do is you start with a vector and you move to a nearby vector, okay. So, and you do so in a clever way so that yeah you get better, right. So, that is what we have been doing until today, right. For all the algorithms that we have worked with until now, what have we done? We try to start at a point and try to go to a point where it is better, right. So, that is what we are trying to do. So, yeah the next step what we are going to do is to throw out one of the variables from the set of basic variables and take in one variable, okay. So, there is going to be an exchange of just one variable, okay. So, let us see how we are going to do it. So, the question basically is, what are the pair of variables that would be exchanged if B inverse B comma 0 were not the minimizer, okay. So, that is okay, at least one of them is not very difficult, okay. So, note that we have the set of all non-basic variables at I mean theta, right. So, that is if you consider Cn transpose minus Cb transpose B inverse n, okay. So, this is an n minus m length vector, okay. Okay. So, yeah these actually correspond to the n minus m non-basic variables, okay. So, the one that I am going to throw out of the non-basic variables, okay, is actually the variable that corresponds to the minimum of Cn transpose minus Cb transpose B inverse n, okay. So, yeah, so let q equal to argmin over I of Cn transpose Cb transpose B inverse of n of I, Okay, so since this is an n minus m vector, so I mean I am writing this in Python language, if you are wondering what this notation means, right. So if you take this vector, the the zeroth element, so it has n minus m elements, right. So element 0, element 1 dot dot dot, element n minus m minus 1, right. So whichever is the minimum, okay, whichever I minimizes is corresponding to the minimum element of Cn transpose minus Cb transpose B inverse n, okay. So I am calling that Q, okay, and I will, so in the next cycle, okay, in the next iteration, xq will be a basic variable, okay. So you can ask me why that is the case, right. So from what we saw here, right, so xn is the set of variables which were 0, right, and if you take the vector theta, right, so the variables corresponding to theta being negative, right. So those are the variables which we are actually going to increase from 0, right. So if this is actually positive, those are not the variables that we are going to increase from 0, right. So you should actually choose one of the variables where Cn transpose minus Cb transpose B inverse n is negative, right. So I am choosing the one that is the most minimum, right. So if you have at least one negative element, right, so the minimum will always be negative, and I am choosing that particular component, okay. So that's the one that I will choose as the basic variable. So we are not done yet, because we have only thrown out a non-basic variable and made it a basic variable. We should know which of the basic variable to be thrown out to be made the non-basic variable, okay. So that we will continue in the next lecture, okay. Thank you.